The electronic component which keeps a track of all your function calls is known as a stack. So a stack is a last in, first out data structure, right? So the best example of stack can be, stacking plates. Now, how do you start stacking plates? You first put the plate at the bottom, and then you keep stacking one on top of each other. And the way you remove things from the stack is by removing the item that is on top of it, right? Hence, that is known as a last in. So the last item that you put first into the stack is the first one that can be removed. Hence, it is known as a last in first out or a LIFO. Sometimes they also call it as a first in last out. This piece of hardware or the stack is referred to as the return address stack. So Intel calls it the return address stack or the RAS, and AMD calls it as the return stack buffer. Let's see how a stack works. Before that, let's take a small program, main IA, then there is a call to function IB. Control goes to function when the call is initiated. Execute all the statements in function, and once it's done, you're going to go back to the place from where you left off. So your stack, it looks something like this. It has many rows here. So there are two operations that are associated with the stack. The first operation is the push, and the second operation is the pop. And a stack also has something known as a stack pointer. The stack pointer gives you the location where you can store an entry. Once that entry is filled, the stack pointer is incremented, so it's going to go to the next location. So let's see how this program works with respect to the stack. Now initially, your program started. So main is your first function in your code. So main is pushed onto the stack. That's the push operation. And as soon as main is pushed, your stack pointer moves to the next location, which means it's going to go to the next location, which is empty, which is right above main. Statements in main are executed. So IA is executed, and then you make a call to function. When you make a call to function, you're going to push function into this stack. After that, your stack pointer is incremented again. You go into the function, execute all the instructions in the function. Now once function is done, we do the reverse operation or the pop operation. So since function is done, we are going to pop out function from the stack. So this is cleared away, and your stack pointer is decremented again, and it points to main. So control goes back to main from where it left off, executes the remaining instructions, and since main has run out of code, main is also going to get popped out. And that is when you say that your stack is empty, and that is an indication that your program is ending. So this is how a stack works with respect to function calls.